Welcome, folks. We are so excited. We have such a fantastic program planned for you all tonight. Of course, our icebreaker question was, have you had a chance to visit the new Space Odyssey? Some folks have, some folks have not. Well, we have a very, very exciting program in which Dr. Graham Lau, who is a space scientist, space communicator, and astrobiologist and research scientist at the Blue Marble Space Institute, who also contributed to the new Space Odyssey and is featured in the My Role in Space component of the exhibition. So if you get a chance to visit the museum, you'll be able to see Dr. Lau. Dr. Lau, we are so excited. Walk us through what we're doing today.
Yeah, thank you so very much for the introduction. Hi, everyone, and thanks for joining. It should be a lot of fun tonight. I got dressed up in my space spenders, and I have a few cool things to show you, but most of this is a talk that I'll be sharing some slides from here tonight. And so let me share my desktop here and get my presentation started for you. So we're going to talk about some really cool things tonight, including tree rings and supernovae and Titan and all kinds of cool stuff. But let's start off with something really awesome that just happened in space. If you didn't know, this past Sunday, we had a rocket launch to space. And this is me every time I see a rocket launch. It's incredible. I unfortunately never had a chance to see the space shuttle launch. I tried once in 2008 to see one of the final launches, and it was scrubbed. Maybe some of you in the audience have seen space shuttles launch. I hear it was incredible to see. I would love to go see one of the upcoming Crew launches as well. Now that SpaceX is officially launching their Crew missions for NASA. On Sunday night, they launched 4 astronauts into space. Soichi Noguchi, Michael Hopkins, Shannon Walker, and Victor Glover all left our Earth on Sunday evening, passing that line called the Kármán line. It's about 62 miles up and marks the place where we say Earth ends and space begins, even though there's a whole lot of space out there, and Earth is really part of space. But if you didn't have a chance to watch that launch, don't fear. I have a video of it, just a short clip right here to show you the launch.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
Cool.
And resilience rises. Not even gravity contains humanity when we explore as one for all. That's the word we want to hear. Stage 1 propulsion is nominal.
Just 30 seconds into this historic mission, flying Crew on board Dragon and Falcon 9. Stage 1 is preparing to throttle down. This is in preparation for max Q, which is maximum aerodynamic pressure.
Stage 1, throttle down.
There's that call out for throttle down.
Power and telemetry continue to be nominal for the vehicle, now traveling at 262 meters per second.
That's really fast.
Falcon 9 is supersonic.
There's that call out. The Falcon 9 is supersonic, and we will be passing through max Q here shortly, the largest structural load during ascent.
Max Q.
And if you're watching on Sunday night, you wonder what that was. Max Q is when the most pressure is being put upon the spacecraft. It's the time when it's the most dangerous, really, for the spacecraft. And it passed through it with flying colors. I watched it live on Sunday night, and I'm still excited to watch it over and over again because rocket launches are really cool. A couple of my friends were even at the launch site in the press booth. They go to the launches down in Florida, and they film the launches, and they took this really cool video. I'm going to play it right now. And they said when 4 humans left Earth last night, they took us with them. And as Falcon neared main engine cutoff, beautiful nebula colors formed in the sky. And I love that so much. This is Mary Liz Bender and Ryan Chilinsky. Their company is called Cosmic Perspective, and they create really cool pictures and audio and video of rocket launches. And they have an upcoming augmented reality book, so you can experience rocket launches in augmented reality and even virtual reality. Isn't that really cool to see the color from the engine as it's flying into the sky? If you had a chance to watch that launch, you might have noticed something else really cool on Sunday night. This is the view looking in the cockpit where you see the astronauts with their suits on, and you can see the really cool screens they now have. Instead of lots and lots of buttons, now they have these interactive touch screens. But you might notice floating down there below them is a stuffed toy. Let's see it right here. Here you can see it floating around. It's a baby Yoda floating around with the astronauts. That's their zero gravity indicator for this flight. If you haven't been following along with a lot of launches lately, a zero gravity indicator is a cool thing that we can take along so the astronauts can show once they've hit apparent weightlessness inside of the spacecraft and things start kind of floating around them. The first launch of Starliner here in the top left shows a Snoopy doll. In the bottom left, there's a picture of a dinosaur that went up. There's also an Earth plush that went up. And now for Crew 1, now we have this baby Yoda. And so maybe a fun question for all of you, if you had a chance to pick something to send up into space as a zero gravity indicator on a space flight, what would you send up? What would you want to see floating around first? And I have a little picture right here. Maybe I can stop my screen share for a moment. And I will show you my little thing. It's a little hard, and I wouldn't want it floating around in the cockpit too much because it might hit people. And so maybe I get a plush version of it. This is called an Inukshuk or Inukshuk. I picked this up in the Canadian high Arctic when I was doing some research up near the North Pole. This was hand carved out of soapstone by an Inuit indigenous person. And it was used by the Inuit, the Eskimo, people of northern lands for a long time to mark their place, to see where people have come and where they're going to mark hunting grounds, and to allow them to better explore in a very remote and barren and often ice and snow covered environment. And so for me, I think it kind of is a guidepost. And so I'd want to take that along with me if I could. I see some other cool things right now in the chat. A stuffed tiger, a plush octopus sounds really cool. Ooh, a stuffed Enterprise. That'd be pretty awesome to see a spaceship go up. I see a Buddha and a unicorn. Those are all really cool ideas. So yeah, it'd be kind of fun if you could pick your own thing to send up as your zero gravity indicator. And we'll see what still has, comes ahead of us now too. Moving forward in the future with all these new launches we have coming, now that we've hit this commercial crew era of space flight, now that NASA can pay companies like SpaceX, as well as perhaps Boeing and Blue Origin, Sierra Nevada Corporation, and others to get humans into space and to the moon and beyond. Here's another really cool picture from Monday morning before the spacecraft was going to dock then at the International Space Station. You can see in the lower right here. And this crew of 4 astronauts, they now join 3 other astronauts on the space station. And the space station now, for the first time, has a crew of 7 people for Expedition 64. And so now they have a long duration mission on the International Space Station, doing experiments on how the human body reacts to being in apparent weightlessness, experiments on exposing microbes to the space environment, lots of various experiments on things that require us having a low gravity environment. And something you might not know, we've now passed the 20-year mark where humans have continuously lived beyond the Earth for 20 straight years. And here's a quote from Carl Sagan from Pale Blue Dot, where he says, "Humans, like the gods of old, living in the sky. And we've now been doing that for 2 decades. That's longer than some of you have been alive who are watching this talk right now. November 2nd, 2000. Since that point, we've always had at least a few people in space at any given time." And one thing I think about a lot as someone who talks about space and loves space exploration and studies stuff involved in space, one question I hear is this: why should we send people to space, and why should we spend money on space when we have so many problems here? And there are lots of ways I could try to answer this question. One thing I would say, if you're interested in how space has given us benefits here on Earth that are tangible, you can go to spinoff.nasa.gov. That's a website where for several decades now, NASA has been publishing and showing us all of the results of how space exploration impacts us here on Earth. So you can go and see how spending money on space and how sending humans to the International Space Station, how that's helped us make better medicines, how it's helped us with surgery, how it's helped us with understanding robotics and artificial intelligence, how we make better airplanes and better boats, better cars, safer cars. There's lots of things that we get out of space exploration. And also, right now, there's a lot going on our world. We now know that the climate is changing very quickly. We now understand there's large-scale environmental issues to worry about with pollution and unregulated mining and all kinds of things on our planet. And we really wouldn't know that without space exploration. We have Earth-observing satellites that are helping us all the time to watch the life and watch the planet here on Earth. And even observing other worlds like Venus and Mars has helped us to better understand our own planet. But one thing I wanted to share, so just yesterday, I did an interview for a local podcast here in Denver. It's called the Low Orbit Podcast. And it's a really cool podcast. It usually features Denver artists and writers, craftspeople, storytellers. And I've come on every now and then to share some science. And just yesterday, I was thinking about one of my favorite books from science fiction called Star Maker by a guy named OLAF Stapledon. He wrote this book in 1937, just before World War II. And in this book, he imagined what it would be like for a human consciousness to leave our planet and to experience looking down at the Earth from space and to experience going out into the cosmos. But one of my favorite things, especially right now about this book, is in the very beginning, there's a 2.5-page long foreword from the author, where he talks about the issues being faced by Europe and by the rest of the world in 1937. And again, World War II hadn't started by that point, but a lot of people saw it coming. They saw atrocities and tragedies and issues in how we were treating each other. And he asked, he said maybe some of the audience might question why he would write a book about seeing the world from space at a time like that. And one thing I really love in that beginning of his book, he says perhaps the attempt to see our turbulent world against a background of stars may, after all, increase, not lessen the significance of the present human crisis. It may also strengthen our charity toward one another. And I think that's maybe even really important for us right now, seeing ourselves as humans and part of this biosphere and seeing ourselves against the background of stars might help us in our current human crisis, especially as a lot of us are dealing with what it's like to adjust to things right now during this pandemic. And there's a lot that we can learn from space. And so I have a few cool, fun things that have happened recently in space research to share with you. First off, you might have heard of a really cool study that came out of CU Boulder here this past month. It was from a researcher named Robert Breckenridge from CU Boulder's INSTAR. That's the Institute for Arctic and Alpine Research, actually right down the street from where I'm at right now. He was looking at how supernovae might affect the climate on our planet and might affect life on our planet. And how this might happen, to understand this, we actually need to look at something called radiocarbon dating. This is a process where cosmic rays coming from our sun and from other stars throughout our galaxy can come to the Earth and bombard materials in our atmosphere. And sometimes in that process, it can make something like a nitrogen-14 atom take in a neutron and pop out a proton. And when that happens, that nitrogen-14 turns into a radioactive isotope of carbon called carbon-14. And that can get mixed into the CO2 that gets breathed in by plants like grasses and trees, things that we eat. And so that carbon-14, as it's being used by living things, it's constantly replenished by the atmosphere. And so there's a constant addition of carbon-14 to the plants around us, to the animals around us, and to us. All of us right now have carbon-14 inside of us from cosmic rays striking nitrogen in our atmosphere, which is pretty cool to think about. But then when things die, that carbon-14 is no longer being replenished by the atmosphere. And so that carbon-14, since it's radioactive, starts to break down, and it can go back to nitrogen-14 again. And when that happens and we lose that carbon-14, we can actually measure that and use that as data to tell us how old something is or how long it's been since it died. And for trees, we can actually look at the tree rings. Since tree rings grow out as the tree goes older and older and older, we can actually look back inside of the tree rings and see back in time. That's also how we've dated the oldest known trees on Earth. Like the oldest single individual tree is a 5,067-year-old bristlecone pine here in the US. And we know that by using radiocarbon dating. Well, in this recent research by Robert Breckenridge, what he saw or wanted to see is whether or not the bombardment from gamma rays being produced by very large supernovae when stars explode, if that could actually also cause an increase in the amount of this carbon-14 that's being added to plants. And one great way to see that is to look at tree rings through time. And so he looked back through about 40,000 years of tree ring data, specifically trying to target 8 recent supernovae that could be compared with them. And he saw for all of them an increase in the amount of carbon-14 in these tree rings at roughly the time when those supernovae are supposed to have happened. Now there could be some wiggle room there, and so there's a lot to learn about this yet. But it also tells us that when supernovae go off near to our star system, near to home, that they can actually affect maybe our atmosphere, maybe plants, and maybe even us. So for instance, we have a very large star, some 640-ish light years away, called Betelgeuse that we think might actually go supernova sometime soon. And if that happens, we don't know yet what's going to happen here on Earth when a large star like Betelgeuse goes supernova. And so by having data like these to look at, it can help us understand a lot more about what to prepare for, potentially, and about how these supernovae through time have affected our planet. Some more really cool recent research you might have heard of. Perhaps you saw in the news this headline that our solar system formed in 200,000 years. That's not exactly correct. What that headline was talking about is some recent research looking at meteorites to try to figure out the timing of when our star went from being an early protostar to becoming an actual main sequence star, to becoming a star. So the way stars form, so we have things like supernovae occurring. When stars get old, they can blow up and blow off their outer layers, or the entire star can explode and blow material out into the galaxy. They can make these giant dust clouds that form all throughout the galaxy. And every now and then, through a variety of potential processes, some parts of these dust clouds can start to collapse and start the beginning of what will become a star system, a new solar system. And as this material is collapsing, a protostar starts to form in the very center, where material is falling onto the center and building up. And as that's happening, the momentum of all these things spinning around starts to pull it all down into a disk, just like you see in this picture over here. And at a certain point in time, that disk ignites. The star goes off and starts to fuse atoms together, and it becomes a real star, heating up the disk. It gets really hot, and then eventually blowing off all the material, but not before planets and comets and asteroids have a chance to form, forming what we later know as a star system or as our solar system. Well, in this recent research, they were looking at meteorites, and I'm going to stop my share here just for a second so I can show you one of mine. This is one of my meteorites. You can see that at home. This is called a Chondrite meteorite. You can see in this a lot of little circular flecks right about here called chondrules. These are really, really old solid materials inside of these meteorites. But there's also things that are even older called calcium aluminum inclusions. And it was looking at those materials that allowed these scientists to figure out roughly the timing for when our star went from being a protostar to being a main sequence star. And so again, here's a picture showing a chondrite meteorite. You can see this big glob right here. That's a calcium aluminum inclusion. They formed something like 4.567 billion years ago. And then right after they were forming, these chondrules started forming. Right after the sun likely started becoming an actual star and went into this phase of blowing off a lot of material. But that formation age of the calcium aluminum inclusions is only about 40,000 to 200,000 years. So it's a very short time window. And what these researchers have shown is that looking at molybdenum atoms inside of these calcium aluminum inclusions, and specifically looking at the isotopes of molybdenum atoms inside of these, they were able to show a large amount of mixing inside of the disk of the sun in that protostar And then right when the calcium aluminum inclusions stop forming, we then see none of this mixing occurring again. Any of them after that, if they're altered at all, they don't have that nice mixing pattern they saw before, telling them that the formation window for the sun to have gone from having a protostar in the middle of a big cloud to being a star was something like 200,000 years, which is really cool. So there's a lot of things we can learn about the history of our solar system, the history of life on our planet, just by studying materials like tree rings and like meteorites. Now, something else really cool I wanted to talk about. I'll see if anyone can guess. Do you know what this picture is of? I'll give you a guess. It's a world in our solar system. And did I lose the chat box? It's a world in our solar system. Oh, I see one right guess. I see a couple for Venus. It's not Venus. I can always talk about that later during the question and answer if you'd like, since we've heard a lot about Venus lately. I see a right answer from Mike Kennedy, a right answer from Charlie Mayer. Ooh, from Rich Olcott. Hi, Rich. So for those guessing, this is actually the moon Titan. Here's another picture that might help a little bit. This picture is showing Titan. So on the left is a picture of the moon Titan. It's a large moon of Saturn. On the right is a picture using ultraviolet and infrared light to look at Titan. And you can see right away this bluish kind of envelope around this world. Titan has a very thick and dense atmosphere around it. At the surface of Titan, it's about 1.5 times the surface pressure we have here on Earth. And it's very, very thick as well. Where the humans are at here on the International Space Station around Earth, if they were at that same distance away from Titan, they'd still be well inside of this big film of atmosphere around Titan. Well, one thing you might have heard of is we actually have a new mission heading to Titan very soon. Hopefully it'll launch by 2027. It has been postponed once. A lot of missions are being affected right now because of the pandemic, but hopefully by 2027, we'll see a launch of this spacecraft. And this is an artist's impression of what it will look like. It's a spacecraft called Dragonfly. It has 8 little helicopter blades. If you can see them right here, there's 4 on this side. You can see there's 4 on the other side. So Dragonfly is a drone that's going to fly around on the surface of Titan and allow us to collect a lot of data about the surface, to learn more about the chemistry going on there. Titan is a very cold moon, but its surface is really different than most of the other moons of our solar system and way different than Earth. The surface is covered in a lot of hydrocarbons, a lot of gunk, of methane and ethane. On Earth, where we have a hydrological cycle, where we have water evaporating and making clouds and then condensing the clouds and then raining down, precipitating down as rain and snow. On Titan, there's a methanological cycle. So methane is evaporating and going into the atmosphere of Titan, where it's interacting with light from the sun and making a whole bunch of other molecules in the atmosphere that are then raining down, in some places even making lakes of a bunch of hydrocarbon gunk. And so this spacecraft, Dragonfly, is going to buzz around and collect data about those hydrocarbons, about the ice, to help us learn more about the surface features on Titan. We did have one mission land there not too long ago called the Huygens Lander, but Dragonfly is now going to really let us learn a whole lot more about Titan, which is really, really cool. And I also want to plug next Tuesday at 11 o'clock here Mountain Time for my show called Ask an Astrobiologist, which comes through NASA Astrobiology. I'll be speaking with the deputy principal investigator of this mission, Melissa Trainer. So she and I will be talking about the mission, about the spacecraft, and about what we think we'll actually learn about Titan when we get there. So if you want to check that out, you can go to astrobiology.nasa.gov/askanastrobiologist, and you can learn more about how to watch my show next Tuesday and ask questions for Dr. Trainer about this mission. I see a question coming up in the chat. Will Dragonfly come back to the Earth? So no. Most of our missions that go to space never come home, unfortunately. You might know right now, we actually have 2 missions that have taken samples from asteroids and they're coming home. That's OSIRIS-REx and Hayabusa 2. And also right now, the Perseverance rover that's going to Mars. Perseverance is going to collect samples that we hope will one day bring back to Earth so we can study them. But Dragonfly is actually going to stay on Titan until its power runs out, and then it'll be on Titan forever. The same way that the Huygens lander is just sitting right now on the surface of Titan. It managed to land. It took some really cool pictures and some data for us. And now the spacecraft is just there, unfortunately. Much like how Mars has a whole lot of spacecraft that we sent there and never brought home. So who knows, maybe in the not too distant future, we'll actually go to Titan as humans and explore, and maybe we'll walk around and find some of these old missions that we sent there long ago. But I also want to focus a little bit tonight on the new Space Odyssey exhibit. I did see when you were answering, for most of you joining in the beginning, that a lot of you haven't had a chance to see it yet, and that's totally okay. I understand as well. Here's a really cool video with some images and some of the cool things going on in the new exhibit. You can also check out the new virtual walkthrough on the YouTube page by Naomi, where she has a 10-minute walkthrough. There's lots of cool things for family to do. I had a chance to visit with my family, a lot of things for kids of all ages to see. We've taken some of the old exhibits, things like showing orbits and how gravity works. Even this, pretty cool. This is new for the new exhibit, where you get to stand inside of a rocket engine during a launch, and the ground shakes around you, and you get to hear the sounds of the launch around you. It's really cool. And again, I totally understand that some of you aren't quite ready to be there in person. That's entirely okay. The museum is doing everything they can, though, to be very clean, very safe. Surfaces are being cleaned all the time. They have a limit on how many people can go into the exhibit. So this newly renovated Space Odyssey, it's now open if you want to visit. I highly recommend it. They worked really closely with the community in designing this new experience. I have to plug myself a little bit. I'm also in the new exhibit. So I think it's really cool and definitely worth checking out. And like I said, I had a chance to take my family down there. It has something for a space nerd like me to start off with that I really enjoyed. One thing I love about space and space exploration is our human connection, our human history with space exploration. And one thing I really love in the very beginning of the exhibit, before we even get into current missions and rocket launches and spaceships, there's a whole section talking about how we humans through time, including local indigenous or fairly local indigenous peoples here in the United States, in the Americas, how they saw themselves in space and how they crafted stories about the heavens around their knowledge of who they are. There's a lot that humans have learned through time about ourselves, who and what we are, just by looking at the heavens and seeing ourselves in the cosmos. Here's a cool picture. This is my son, Nolan, checking out the panorama here, the diorama on Mars. And this is me under that rocket engine. It took my wife quite a long time to make me leave. It was really cool to feel all these different rocket launches going off. It was a lot of fun. There's also a new cratering exhibit. So for those who've been there before, we had the old cratering exhibit that launched these metal balls. This one's really cool. It blows a little bit of air, and you can actually change the pressure and the angle at which you're blowing the air. And there's a really cool slow motion camera kind of going off on the side to let you learn more about how craters are formed, which is a really important thing for scientists to understand, for understanding the history of our solar system, of worlds in our solar system. Again, this is my son just checking out some of the cool stuff and flying some spacecraft. And then there's a picture of me. I have to plug myself. And I'm very happy and honored to be a part of the exhibit, to share more with you. I'm happy to share with you in the exhibit when I can, and always happy to share online virtually as much as I possibly can as well. It was a lot of fun for our family to go and experience the new exhibit. Again, they're following all of the health guidelines to ensure that everyone has fun, that all of your experiences are safe when you visit. And again, regular cleaning is happening. There's limited capacities and it's reservation only. But please do register if you're interested in going. And if not, we'll still be here for 60 Minutes in Space. But there's one thing that I want to point out. If you get a chance, and you do have a chance to tool around, this is a really small thing, so it'll be a little hard to find. But there's this one little placard on the wall that I found with some really pretty language that says all of human history happened on a tiny blue dot. Every hardship, every joy, every birth and breath happened here. And here is a small place. Humans have spent millennia stargazing revealing a universe greater than we could have imagined. As we uncover the amazing vastness of the universe, we are reminded of the incredible preciousness of our humble blue globe. Will humanity ever leave or live on another planet? The answer to this question is unknown, but one fact remains undisputed. Earth is where we live now, and it is the only planet we can truly call home. I love that little placard. I'll tell you what, if you're in Space Odyssey and you find that placard, take a picture of it and send it to me. I'd love to see where you found it. I included a picture here on the left of a really famous picture from NASA called the pale blue dot. This is a picture that was taken in 1990, in February of 1990 by the Voyager 1 spacecraft. It was about 4 billion miles away from home. And we decided to turn the spacecraft back around and to get a snapshot, a family picture of a bunch of the worlds, most of them at that time, around the sun. And included in that was this little dot, this little blue dot, and that's our home. That's the Earth. And one of the things I love about Space Odyssey, that I've always loved about the Space Odyssey exhibit, is that it tells us that, and we have lots of great exhibits around inside to show us that space exploration is more than just going into space. It's also looking back here on Earth and learning more about ourselves and who and what we are. And so I think with that, I'm going to stop my presentation. If any of you have any questions, I'd love to talk. For those who know me, I could talk forever. But if there's anything about what I spoke about you want to talk about, or maybe about Venus, feel free. I'm happy to take any questions you have now.
Thank you so much, Dr. Lau. Like he said, we're still taking questions. I do have a few that I already pulled, but if you have anything that you want to know more about, something that was in the presentation, maybe something that wasn't, you might not be able to see each other's comments, but we can see them on our end. So we do have some questions about the Dragonfly. One of the questions was just, how big is it?
Ooh, I actually do not know the answer to that question. I will have to ask Dr. Trainer on Tuesday next week. I did see a really cool picture on Twitter today. They just had a science meeting and they posted a really awesome Zoom picture of all the different people taking part in this mission. And it's a huge mosaic of pictures of different people from around the country, around the world, who are taking part in this mission. So I'm really excited on Tuesday to talk to Dr. Trainer about the mission. And I will ask her that question and try to learn more myself about how big this spacecraft will be. But it will be really cool to have a spacecraft with 8 propellers, a big drone like that. Some of you might know that right now, on its way to Mars, along with the Perseverance rover, is our first drone that will fly on another world called Ingenuity. Was actually named by a 17-year-old high school student. And it's a really great name. And this is going to be a test of flying drones on Mars. This one has just 2 very large propellers, and it's going to take off of the back of the rover, basically, and then do some little hops around Mars. It's not going to do a lot of science because it's more of a test, but it's going to be really cool. I really hope that we have a chance to see some of it hopping. If we can get the cameras from the rover facing it, we'll see if that's actually possible.
Wow, that's really neat. We do have another Dragonfly question. And again, we put up the link if you want to watch Dr. Lau's talk next week. The other question was just, how long will it take to get there after it launches?
That's a really good question. And it kind of depends right now on which rocket we're going to launch it on. So some of you might have heard of the Space Launch System, or SLS. That's a rocket system that NASA's been working on for some time. That may or may not be ready, if it ever is ready. It's had a lot of issues in its development and planning. There's a large portion of the community who aren't even sure if we should actually continue forward with it. But it will be a heavy launch vehicle that can launch really fast and get the spacecraft there a lot quicker. And so for like Europa Clipper, which is a spacecraft going to Europa, a moon of Jupiter, for Dragonfly going out to Saturn, and for a lot of our upcoming missions, having a larger rocket that can get us there faster is really cool. The faster we get there, the sooner we can do that really cool science. So if we get that, then maybe Dragonfly could get there in like 4 or 5 kind of years, somewhere in that kind of range. Otherwise, it could take quite a bit longer.
That makes sense. Are there any other missions that we can look forward to before 2027?
So then there's a bunch going on. Obviously, right now, I'm really excited for Perseverance, which is on its way to Mars. It'll land in February. There were 2 other spacecraft launched to Mars in that same window this past summer. And so we have 3 whole spacecraft on the way to Mars right now, arriving there early next year. And 2 of them will have landers with them. So that should be really cool. Right now, there's a spacecraft called Bepi Colombo. It's traveling to Mercury. And it actually just did a flyby of Venus, and we'll do a second flyby of Venus late next summer before it then continues on to go to Mercury and do some cool research there. I mentioned Europa Clipper. Well, we also have a mission coming up from the European Space Agency called JUICE for Jupiter Icy Moon Explorer. That one should launch hopefully in 2024, 2025, around that time frame. There's a bunch more missions planned for Mars coming up, not just from the US, not just from NASA, but the European Space Agency, the Japanese Space Agency, and the Indian Space Agency, ISRO, all have plans to send more things to Mars.
That's super cool. And one of the unique things about the SpaceX mission is, of course, this public-private partnership that's happening. Noel wants to know if that's going to be the norm, if we're going to be looking at those partnerships in the future, and what can you tell us about that?
Yeah, I mean, this has been a big thing for a long time we've been talking about. And you might hear the word new space or the term new space a lot when we talk about what's going on right now with private industry coming up in space exploration, but it's actually been happening for quite some time. It's just burgeoning right now in a very new way. And now we see organizations like NASA really taking it seriously, that rather than having to pay large-scale contractors for a long-term plan, they can go to different companies. SpaceX right now isn't the only company working on getting humans into suborbital flight, low Earth orbit, or beyond, perhaps to the moon, to Mars, maybe even further. There's other companies like Blue Origin, Sierra Nevada Corporation. Virgin Galactic is going to be launching their spacecraft, or their suborbital craft, to take humans up and have a suborbital flight where they'll have the experience of seeing the curvature of the Earth, not going fully up into low Earth orbit. But there's a lot of really cool things coming up. There's some plans from private companies for balloon launches to take humans up really, really high in the atmosphere. If you remember a few years back when Felix Baumgartner made the highest skydive on record, when he jumped from the top of the atmosphere back into the Earth. We'll have people going up in balloon missions like that way more often. I think it's a really cool thing. I hope we see a lot more of it, not just in the US, but around the world. As more nations right now are developing their own space organizations, their own space infrastructure. More nations are getting involved in satellite technology, telecommunications, GPS, and those kinds of things. We're also going to see a lot more nations wanting to get involved in sending humans, sending robots, and doing more exploration. And private companies can help us make that happen a lot faster. And they can compete with each other, bringing the prices down and making it more affordable. And especially if they can do it with a lot of reusable rockets. That's one thing that I'm really looking forward to as well.
Fingers crossed for reusable rockets in the next 10 years. I don't know. That's an arbitrary number. So we have a few people in the chat that are curious about moon bases or Mars bases.
Ooh,
so the question is, do you foresee a base in either spot in our lifetime? And if so, which do you think will come first?
Yes. One thing I will say, I remember when I was a teenager, when I was 13 years old, I went to space camp in Alabama, and I loved it. It was a beautiful experience. But one thing I remember being really excited about then was the counselors telling me that in 20 years, your generation will be the very first to walk on Mars. And it's past that point now, unfortunately. But then I remember, like, in college, people were saying in 20 years, we're going to walk on Mars. And every now and then I still hear people say that in 20 years, we're going to do this. In 20 years, we'll do that. 20 years seems to be like that limit that people put things at when they really don't know when it's going to happen. And so what I really want us to do is to have a long-term vision, maybe even not just as people from the United States, but people from all over the world, to develop a long-term vision that can get us somewhere, be it the moon, be it Mars. Right now, due to politics and issues with funding, we change the goalposts every 4 to 8 years right now. And I'm hoping that soon we have a longer strategy for getting us to the moon, for getting us to Mars, and making it sustainable, something that brings value to all of us, but also allows us to keep exploring. and to do so in a way that's also not contaminating those environments either.
So when you talk about that long-term vision, what do you hope to see in it? Like, what do you hope that the priorities are based on the science that we already have?
I mean, yeah, there's so much we can do. As an astrobiologist, I want to see more robots going out and surveilling all the worlds of our solar system. I also want to see a lot more space telescopes. There are some next generation space telescopes coming up. The James Webb Space Telescope unfortunately got postponed again, but right now we're looking at October of next year. Fingers crossed. I really, really hope we have that thing launched soon. I've been waiting for it for years. People have been waiting for many years for this to launch. It's going to be a really cool telescope, but there are other really awesome space telescopes in the works as well. I think in the next 5-10 years, not only will the number of exoplanets that we know of burgeon from the 4,200 roughly we know right now to tens of thousands, but we're going to start looking into our atmospheres, looking for signs of potential biological activity, looking for signs of potential technological activity. I think in our solar system, I'm really excited to see more robots going to places like Europa and Enceladus and Titan, and exploring the icy worlds, exploring more of Venus and more of Mars, and teaching us about the history of our solar system and helping us figure out whether or not there could be anything else living here. But for human space exploration, I really want to see us start pushing further. And I'd love to see humans go to the moon again. I'd really love to see the first woman walk on the moon. And I think we could do that very soon. I don't know if 2024 is going to happen. I think a lot of us thought that was a little bit too soon. But I think if we work together on that and really keep that vision alive, we could actually make Artemis happen still, to get us back to the moon and then get us to Mars. Having humans walk on the surface of Mars would be a dream come true for me.
Hopefully within the next 20 years, we'll be able to do that. So we're still getting in some questions. Again, if you're curious about anything, we might not be able to pull all of them. I'm pulling as many as we can. We do have 2 quick questions that I want to clarify for everybody. Somebody asked, is the new Space Odyssey geared just for littles? I'd love to hear your experience, and then I'll give you the DMNS answer.
Well, my answer is no. I am a father, and so it was fun to watch my 16-month-old run around, and there is the AstroTots area for the young children to play. It has some activities that are a little better for the toddlers and some of the younger children. But there's also a bunch for us, older children as well to play with. As a huge nerd for meteorites, I love the new meteorite exhibit that we have. The Canyon Diablo piece is still there. You can still touch it. It's a very beautiful meteorite as well. But there's something new there as well. And I hope you go and see it. And yeah, I think there's a lot of cool things for me to see. I've always loved the infrared camera. Like I said, standing inside of that rocket, launching and hearing the sound of it and feeling the ground shake, that was a lot of fun. There are 3 different spacecraft you can experience the launch from for that. You can also drive the rover on Mars instead of the diorama, which is really cool. So yeah, there's a lot of really cool stuff in the exhibit for adults as well. And Science on a Sphere is fortunately still there. It's one of the coolest things in the exhibit for me. Science on a Sphere allows us to see spherical projections of data, including maps of the Earth, maps of other worlds. You can look at climate data, water data, geological data, data about biology, all kinds of cool things. If you ever see me there, ask me. I can take you for a tour on some of the different data sets that we have on the Science on a Sphere. But yeah, so what is the DMNS official statement?
It's that it's fun for everybody. One of the biggest things when we were redesigning Space Odyssey was really getting this community input. It was more than just on-site staff. I mean, Dr. Lau, like I said, is represented in that. So we heard everybody, and there's something for everybody in there. As an adult, you'll find your kid in there, definitely, but there's plenty of, I think the Indigenous stories that you pointed out is just one of those moments where you sit down and you listen and you learn. There's so much to learn from there. So there's, like I said, there's something for everybody.
Yeah, and I love it, the way that you walk through the exhibit as well. Like if you go through it and you kind of come in, you see this history of humanity and our understanding of the heavens and space. You see an exploration of some archaeological sites on Earth and what people through time have thought and how we've built structures to understand the heavens above, like pyramids and various things like that. And then you have a chance to kind of interact with some of our current things in spaceflight, like the rocket launch engine, like the surface of Mars. You can see how we collect various kinds of data. The infrared camera, for instance, you can look at orbits of planets, orbits of things around different kinds of masses to see how orbits actually work and how gravity works through our current knowledge. And then you can kind of go a little bit deeper into going into an actual spaceship, where there's a lot of really cool things to do inside of this spaceship that I think is a blast for the whole family.
I agree. And that's, we're getting some chats that say that too. Diane said that she is 68 and loved it.
Aww.
And again, for folks that aren't able or comfortable going into indoor spaces, closed indoor spaces right now, that's okay. Of course, the museum is doing everything we can to keep everybody safe. But we also have that really cool tour that Naomi did. She worked so hard on it, and it looks amazing. I saw it before I went in, and then I got to have both experiences. And then let's see, I'm now scrolling. Let me make sure I didn't miss anything. Oh, early on in your presentation, somebody asked about how you're able to differentiate from really bright solar flares and supernovae.
Yeah, so that can be really hard. And that's also one of the issues in the paper that the scientists brought up, was that we don't really know. It can be really difficult. There could be some ways to look at that geologically, to look for other signs of cosmic ray and specifically solar cosmic ray bombardment. But it is really difficult to tell. It does look like there is an increase, though, in the timing right around when those supernovae happened, not too long later, of this increase in the carbon-14 in those tree rings. But that's a very good question, because it really could be hard to tell. There's a lot for us to learn yet in that realm. Something else that he pointed out in the paper was that we don't actually have an exact date for some of these supernovae. The more recent ones that humans have actually observed and written down in record, we know the timing of those, but ones that are tens of thousands of years old, it can be harder to actually pinpoint the exact year, even within a few decades or even centuries of when they happened. There could be a large wiggle room there. And so there's a lot more for scientists to consider with that paper. There will always be debate around the science. I'm sure someone else will either question those results or will find other data to support those results.
Maybe we'll see something in our next 60 Minutes in Space.
Exactly. And actually, I do see a question here about Venus. And so maybe it's a good time to mention that as well. So I know it might have been the last 60 Minutes in Space, perhaps. Recently, David Grinspoon joined in for a 60 Minutes in Space to talk about that recent finding of potential phosphine within the atmosphere of Venus. So if you hadn't heard, a research team using two different telescopes here on Earth looking in radio waves. We're looking at the emission of radio waves from Venus here on Earth, and they found a little dip in the emission right at a certain place that could be an indicator of the molecule phosphine. That's a phosphorus atom with 3 hydrogen atoms around it that are bound to it. And the reason that's kind of cool is because here on Earth, the only 2 ways that we know phosphine can form is either we form it in the laboratory, industrially, or it forms in nature through biological processes. Specifically in environments without much oxygen, where microbes are present, certain kinds of microbes can form this molecule called phosphine. And so finding it on Venus could be an indicator of potential Venusian life. And again, they had 2 different telescopes. One was the James Clerk Maxwell telescope in Hawaii. The other was an ALMA telescope, the Atacama Large Millimeter Submillimeter Array down in the Atacama Desert in South America. And both of them had that little single dip showing this potential phosphine. A few caveats, though. We have found this molecule phosphine in Jupiter and in Saturn. And so we know it forms in other places and probably without life. But the models that we currently have for how it chemically forms on Jupiter and Saturn is that it forms down low where there's a lot of pressure, a lot of hydrogen, and the temperature is very high, and then it goes up higher in the clouds. And we don't really have the same kind of environmental process on Venus to look to. Venus isn't a gas giant like Jupiter or Saturn. And so the team who announced this phosphine finding also announced they didn't really have any good explanation besides life for what could have formed it. However, that said, that doesn't mean there's not some volcanic or geological process occurring or some photochemical process occurring due to sunlight forming it. And it's also possible it's not there. And so that's been the big buzz now. And so science, when we have these kinds of results in science, one of the important things for us to do is to question them, to question the results, question how the data were collected, to reanalyze the data, and to think about if it is there, how do we actually figure that out for sure? And so there's been a few other papers over this past month and a half questioning that finding, giving alternative explanations for what that dip could have been from. But then just yesterday, the authors of the original paper released a preprint, so it hasn't been peer-reviewed science yet, but they released a statement that they still stand by this being phosphine, that they reanalyzed it. They're pretty sure it's phosphine. Like I mentioned earlier, Bepi Colombo is a mission that we're sending to Mercury, but it is flying by Venus again late next summer, and it actually might be able to take a measurement to look for that phosphine if it even is there. And also, we have other potential missions. Another private company called Rocket Lab is actually planning a Venus mission, and because of this potential phosphine finding, they're now thinking about how to get a potential life detection instrument to look for that phosphine, to look for potential life on Venus onto that spacecraft as well. And that could launch in just the next few years.
That's so cool. And I love always hearing, especially a scientist's perspective, about that dialogue that happens within the community. I think it's always important to know. It's question it and then prove it, or question it again. Let's see. Oh, we've had a few different questions about this specifically now, so it's more fun. Just curious as to what your sci-fi recommendations are, especially now that some folks are on lockdown.
Ooh, that's a really good question. I do have to say I'm very sad that the new movie Dune was delayed for a year to next year. That's kind of saddening for me. I really love Dune a lot. I read the novel once every year. I'm a huge fan of hard science fiction and science fiction horror. But right now, there's also just some really cool sci-fi you could watch to tell some fun, beautiful stories about who we are. Interstellar is one of those that I'd recommend. One, they had real scientists collaborating with them, talking about what it would look like to approach a black hole, how we would understand gravity in different kinds of situations in different worlds, even around black holes. One of my favorite movies as an astrobiologist, I have to watch Contact. It's a beautiful film. There's a novel that's based on, written by Carl Sagan. And the main character of the film, Ellie Arroway, was based partly on David Grinspoon, who used to work at the museum, as well as on the SETI scientist, Jill Tarter. And I've been lucky enough to have Jill on my show to talk with her about her experiences of knowing Carl and Anne, and having a character, such a cool movie based on her, which is really awesome. There's really great sci-fi out there. There's also a lot of great stuff on television right now. I love Westworld on HBO. I think it's really cool for a science fiction dip into artificial intelligence and what will be coming next. For my show, I also had someone else on my show. She is the current chair of astrobiology at the Library of Congress. Her name is Sue Schneider. And Sue studies what the future of our species might be. Will we become an artificial intelligence ourselves? Will we merge into machines? Will we become post-biological life? And she's writing a book right now. It's not released yet, and hopefully she'll have it out sometime in the next year or so, about what aliens might be like. Are we more likely to find post-biological aliens if they're out there? Is it a necessary thing? Does life have an imperative to create a large biosphere and then to create a post-biological, artificial, intelligent life form? We don't know. And so she's kind of exploring that realm of SETI right now, exploring what intelligence really is in various organisms like dolphins and spiders and corvids like ravens and crows and all those kinds of things. So there's a lot of great sci-fi out there. I could recommend sci-fi all night, I swear.
Well, a few folks are saying thank you for that, and I am one of them. Let's see. So somebody asked earlier if you would happen to know, and it's okay if you don't, what the job description of a principal investigator for a space mission is.
I don't know what the job description necessarily would be when they look for one. But so this principal investigator is called a PI. And so the way that you become a PI is you're the very top person on the grant that gets submitted to ask for money to fund something. And that could be a mission to go to space, or it could be a much smaller grant. You could be the principal investigator on a small research grant. Maybe you want to go to the rainforest and look for new species of amphibians in the rainforest. You could be a PI on a research project to do that research. So there's different kinds of principal investigators out there. I've never been one myself, but just recently in the past couple of years, NASA's been pushing more to help early career scientists, so undergraduates, graduate students, and postdoctoral students to learn more about how to apply to become principal investigators, how to be the lead people for these large grants, especially for missions to space. Because it is a really important position to have. Not only are you the person kind of driving the vision of the mission or the research, but then you're also, especially if it's a space mission, you're in charge of a very large team of people. So for Dragonfly, like I mentioned, I just saw that picture on Twitter of this big mosaic of Zoom pictures, and it's so many different people from different places doing all kinds of research to help this mission move forward. And the PI of that mission, they have to be kind of the person who helps to corral everyone together so that it can all get done.
That is super cool. So there you have it. You might, if you're an undergraduate or early on, or maybe you're not yet in college, there's some really cool opportunities coming up. So we have time for one more question, or if you've seen something in the chat that you want to point out, now is a great time to do that. Otherwise, we've had this question, I think, 2 different times. People are just curious as to what you're up to, what you're currently working on, any fun projects that you want to talk about.
Well, thank you. So one, I currently have a paper in the works on some research that we did in the high Arctic a few years ago, looking at a geological feature. Sometimes it's called a gossan here on Earth. It's a mineral-rich feature that's really red on the top because metal inside of the ground near the surface gets weathered and creates iron sulfide minerals. And these iron sulfide minerals and iron oxide minerals, they make a bunch of red coloration on the surface. And in the Arctic, where there's not a whole lot of vegetation, so there's not a lot of trees and shrubs and plants to cover up all the rock, you can fly over in helicopters and airplanes and look down, and you might even see a big circular red area where this weathering has happened. And we also have good reason to think that these kinds of features might exist on Mars. We haven't driven over one with a rover yet, but it's quite possible it could happen. Maybe Perseverance will be the first. And these features could be important for us to understand some of the last refuges for life near the surface of Mars if it was there. And so the paper we're working on is looking at the mineralogy, the chemistry of these features. I also do a lot of communication of science. I do a lot of talks and sharing science. I'm giving a talk tomorrow night to some middle schoolers about weird organisms on Earth and how they might teach us about extraterrestrial life. I do a lot of podcast interviews talking about things like the Phosphine finding on Venus. And I'm also a research scientist at the Blue Marble Space Institute of Science. And part of my work right there this summer, I brought on 19 interns, mostly undergraduate students. A couple of them had already graduated from college to do research with me. Some of them were doing work in how do you communicate science? How do you effectively write for the public about what we're learning in science? But then another group of them were working with me on a project from NASA Ames that I'm working on, where we're developing a database of all of the biosignatures, all of the signs of life that we know of that we might use on our future missions to say whether or not we've actually found life on another world. And the students, their job was basically to do a bunch of research on different kinds of biosignatures to help us build up this database.
What a cool project to be a part of. So 19 different interns, that's awesome. Are any of them watching today?
I see someone, Jen. I was part of that group. It's such a cool opportunity. Awesome. Thanks, Jen.
Hi, Jen. Awesome. Well, that's just about our time. Do you have any parting thoughts that you'd like to give our guests?
So yes, back to Star Maker and Olaf Stapleton. I highly recommend you read it. It's a short read and a really beautiful story. I don't want to spoil it, but there is a paragraph in there that I'm pretty sure was the basis for Carl Sagan's Pale Blue Dot speech. And if you read the book, you'll find it. But again, one reason for me, especially right now, that I really appreciate stories like that is that it's good for us, especially at times like this, when we are separated, when some of us are alone, when we have, not as much of our social network to call on. And as a side, I do prefer physical distancing over social distancing. We can be social together. We can come online in virtual events. We can talk on social media. We can connect online and call each other and email each other and send letters. But we should be physically distanced still to be safe. We should wear our masks in public to make sure we're caring for each other. And this is really hard for a lot of us. And so it is hard. It is depressing for some of us. And I think in those times especially, let's all just remember that we are on this one fragile rock in space together, in this void of space floating together right here, right now. We are the culmination of billions of years of life on this biosphere, and we're now taking it to the heavens beyond us. And that's something really grand to think about, especially at a time when a lot of us are a little bit more separated than usual.
Thank you, Dr. Lau. That was a very inspiring outro. Thank you all for joining us and for being with us. For those of you that this was your first event, thank you. We're so excited that you could join us. For those of you that have been here many, many times, we're very grateful for your continued support. Like we said, we hope that we'll see you at the new Space Odyssey. Make sure you grab your tickets beforehand and you're able to, again, they don't cost anything. They're included in your admission. They just help us keep you safe. So with that, thank you. Have a good night, everyone.